Greetings everyone. This video is specifically for qualitative analysis of organic compounds for class 11th. In this video, I'll be discussing that how to detect the presence of carbon, hydrogen and extra elements in a given organic compound. As we know that organic compounds are defined as hydrocarbons and their derivatives. So first of all, we have to detect the presence of carbon and hydrogen in the given organic compound, and that is a very easy process. We just have to heat the organic compound with copper oxide, as you can see here in the equation. Copper oxide is an oxidizing agent here. So on heating the organic compound with copper oxide, the carbon which is present in organic compound will change to carbon dioxide gas, and hydrogen will get oxidized to water vapors. Now, how to check that the gas which is coming out is having carbon dioxide and water vapors in it? It's a very easy method again. We will just pass carbon dioxide through lime water. You know that calcium hydroxide is lime water. You have done this in class 10th, that when you pass CO2 through lime water, it turns milky because of the white precipitation, turbidity, due to the formation of calcium carbonate, which is a solid here. And to test that water vapors are also there, we'll simply pass the water vapors through copper sulfate anhydrous, which is white. And after passing the vapors through copper sulfate, it turns blue, which confirms the presence of water vapors there. And again, what is it confirming? It is confirming that the organic compound had carbon and hydrogen. That is how we got CO2 and H2O, and we confirmed by passing them through the respective chemicals. After this simple detection of carbon and hydrogen in the organic compound, we have to now detect whether the other elements, or sometimes it is written as extra elements also, whether they are present in the organic compound along with carbon and hydrogen or not. The other elements I am talking about are nitrogen, sulfur, halogens, and phosphorus. But it is not easy here to start with the detection in organic compounds for these extra elements. We have to make first a particular extract which we call Lysines extract. I'll just tell you the purpose of making it and what is it exactly. We are talking about organic compounds. So organic compounds, they have carbon in them, they have hydrogen in them, and extra elements we are going to find out now. Right. If I have, suppose, an organic compound with chlorine in it, and I compare it with something like NaCl. Now both of them have chlorine, but what is the major difference? The difference is here in this organic compound, the carbon chlorine bond is not that polar that it will give you the chloride ion when you put it in the solution, as compared to this NaCl, which is purely ionic in nature. So as soon as you put it in water, it is going to dissociate to give you Na plus and Cl minus. And we simply detect the presence of Cl minus by putting AgNO3, and we get the precipitate of AgCl, as simple as that, white precipitate, which is completely soluble in ammonium hydroxide. But if I have a compound like CH3Cl or maybe CCl4, it has 4 chlorine atoms in the molecule. Still, if you put AgNO3, you are not going to get even a single mole of AgCl out of this reaction. Same reason, that carbon and halogen bond is covalent in nature. So first of all, I have to make a particular extract by which I will convert the covalent form into the ionic form. And why do we want to do that? Because then the detection becomes very easy, like normal salts that we do in chemistry lab. So what are we going to do? We are going to fuse the compound, react the organic compound with sodium metal. If nitrogen is present in the organic compound, as you can see here, carbon will be there, obviously. So if nitrogen is also present, then it will give you sodium cyanide, and then it becomes the ionic form, Na plus Cn minus. You can easily detect it by chemical reactions. And if sulfur is present there, it should be Na, sodium. If sulfur is present there in the organic compound, then it is going to convert to S2 minus, that is sulfide. So I get sodium sulfide. Same way, if halogens are present, then they'll be converting to the halide. So what is the purpose of making the Lessines extract? This particular test that we are discussing now is called Lessines test, as mentioned here. And what is the purpose? It's a very good important reasoning question. The purpose of making the Lessines extract is to convert the covalent form into ionic form for easy detection of extra elements. Now, detection of nitrogen. Now here we start with the Lessines extract, which is also called sodium fusion extract. So how will we test the presence of nitrogen? First, it is converted to NaCN, as you saw on the previous slide. And then this is treated with ferrous sulfate. Iron 2 sulfate is ferrous sulfate, that is FeSO4. So I will take the sodium fusion extract that we made and I'll boil it with ferrous sulfate so that I get this complex. And this complex is then acidified with concentrated sulfuric acid. In that process, this complex, which is made in the first step, is going to react with Fe3 plus now, and it is going to give you blue color instantly on acidifying. That Prussian blue color confirms the presence of cyanide. If you don't get the blue color, that means cyanide is not there. And if cyanide is not there, that means nitrogen was not there in the organic compound. But if you get the Prussian blue color, that confirms the presence of nitrogen. Simple testing. And it's a very easy test. It comes instantly. The only thing is you should make sodium fusion extract very carefully. And then once it is ready, the detection of extra elements is very, very easy. Now, if I have to test for sulfur, next extra element, what will we do? This you already know from where it has come. It has come from the sodium fusion extract. When you fused sodium metal with the organic compound, then from there sulfur reacted with sodium and we are getting sodium sulfide, Na2S. Now there are two possible tests which can be carried out very easily in the lab. You take that sodium fusion extract and treat it with acetic acid followed by lead acetate. In that acidic medium, lead reacts with sulfide and gives you a black precipitate of PbS, that is lead sulfide. Another test is take the sodium fusion extract. This is representing that only, otherwise you can write Na2S. So that sodium fusion extract reacts with sodium nitroprusside. Now, don't get confused. This is a way of writing the equation. This is basically ionic equation where we are just representing the ion, sulfide ion, and this complex ion. So this is nitroprusside ion. Sodium nitroprusside, if I am calling it, you can see you have two negative charge here. So you can simply write Na2 here. It becomes sodium nitroprusside. So here we are talking in terms of the ionic equation. You can write the molecular equation also. That is up to you. So when sulfide S2 minus reacts with FeCN5NO2 minus, which is nitroprusside ion, it gives you a violet coloration if sulfide is present. Because of the formation of this complex, this is violet in color. So what has happened, if you see the reaction carefully, the S2 minus has come in the square bracket, and because of that this 2 negative has changed to 4 negative, because 2 negative comes from sulfide also. This way it is easy to remember the reactions. That is why I am explaining in this manner. So there are two tests by which I can confirm that sulfide is present in the organic compound. Now something very interesting. Suppose here in this particular detection of nitrogen, you carry out the test in exactly the same manner as I had explained, but instead of Prussian blue color, you are getting a red color. What does it mean? We are carrying out absolutely in the same manner. We are taking the sodium fusion extract and then reacting it with ferrous sulfate and then acidifying it with the sulfuric acid, and instead of blue color I am getting a red color. This confirms the presence of nitrogen and sulfur both. That means both nitrogen and sulfur are present in the organic compound, because if you treat organic compound with sodium, you fuse it with sodium, you heat it with the sodium, and sulfur, nitrogen, and obviously carbon is also there, they are present together, sulfur and nitrogen, it produces NaSCN instead of NaCN, because sulfur has also come now. So this is thiocyanate, sodium thiocyanate, or sulfocyanide we call it. So when this is present and then you are carrying out the reaction, so instead of blue color you get the red color because of the formation of this particular complex, as you can see here. But suppose you want to carry out the test in the same manner as you did earlier, that you want to test nitrogen separately and you want to test sulfur separately. For that also there is an option. You take the sodium fusion extract in which this is present, and you just heat it with more quantity of sodium carefully, fuse it, carry out the fusion with sodium again, and this can be separated to NaCN and Na2S. Sodium cyanide and sulfide are separated, and again you carry out the reaction in the same manner as explained in the earlier two slides for sulfide and cyanide, and you can confirm that yes, both are present there. Now the easy test, detection of halogen. This you must have been doing in the chemistry lab for halides. If you have chloride, suppose, then you will simply add to that sodium fusion extract silver nitrate solution. It will give you a white precipitate of AgCl, which will be completely soluble in ammonium hydroxide because of the formation of this particular complex. In the same manner, we can test for the presence of bromide and iodide in the given organic compound. First of all, we'll treat sodium fusion extract with nitric acid and then add silver nitrate to it. In case of bromide, you will get a pale yellow precipitation which is partially soluble in ammonium hydroxide. And in case of iodide, you will get a proper yellow precipitate which is completely insoluble in ammonium hydroxide. Now, a very important question arises, that why is it important to boil the sodium fusion extract with nitric acid before testing for the presence of halogens in the organic compound? The answer to the question is very simple. It is important because if you have nitrogen or sulfur or maybe nitrogen and sulfur in the organic compound already, they will interfere with the test for halogens. When you put silver nitrate and there is already Cn minus, NaCN in the sodium fusion extract, it will give you AgCN precipitate, which is black. And if you have sulfide S2 minus, it will react with silver nitrate to give you black precipitate of Ag2S. So this is how it is going to interfere with the test for halogens. We want AgNO3 to react with halides and give us the corresponding precipitates, but these will interfere by making the respective black precipitates. So it is very important to remove them before testing for halogens in the organic compound. So when the sodium fusion extract is boiled with nitric acid changes them to HCN and H2S gases, and they do not interfere with the test for halogens then. Now we come to the detection of phosphorus in the end of the presentation. Here the organic compound is first heated with an oxidizing agent so that phosphorus which is present in the organic compound changes to phosphate ion, PO4 with 3 negative charge, as you can see here. And then in the presence of nitric acid, you get phosphoric acid, and this phosphoric acid reacts with a reagent called ammonium molybdate. This is the formula. In the presence of nitric acid again, and in this case, on heating it, you will get yellow, canary yellow precipitation of ammonium phosphomolybdate. This is the test for phosphate, which confirms the presence of phosphorus in the organic compound. So here we come to the end of the presentation. I'll request you to suggest some more topics in which you are facing problem, maybe numericals or any other area in chemistry. I'll definitely make simple videos to help you prepare better. Thank you very much.